Welcome once again to my YouTube channel. Today, we are going to look into a topic in chemistry, stoichiometry. Now, we have a question to answer on the board, but before we look into the exercise there, we need to understand what stoichiometry is all about. As we know, stoichiometry is an aspect or branch of chemistry that deals on quantity relation between the reactant and the product, or reactant and another reactant, or product and another product in a balanced chemical equation. It deals on the quantity such as mass, the mole, or the volume of these reactants and the product as well. So when a question is given, you should bear it in mind that you are dealing on the relation between reactants and the product, reactant and another reactant, or product and another product in a balanced chemical equation, which means the equation must be balanced before you solve anything, before you relate anything. So the question we have here, it says, consider the reaction represented by the equation. We have the equation given. Sodium hydrogen carbonate decomposed to sodium carbonate, carbon 4 oxide, and the water. Then what is the mass of sodium triazocarbonate 4 produced by the complete decomposition of 33.6 grams of sodium hydrogen triazocarbonate 4? So we have to write down the equation first and check whether the equation is balanced or not. So equation of reaction, we are given sodium triazocarbonate decomposing to sodium hydrogen triazocarbonate decomposed to sodium carbonate, carbon 4 oxide, and the steam. We have one atom of sodium here, while we have two here, which means the equation is not balanced. Hence, we need to find a way to balance it. If we have two atoms of sodium here and one here, that means we need to put two here. So the sodium is 2 now. Then we have carbon, 2 carbon, 1, 2. Carbon here, we have it 2. Hydrogen is 2 here. Hydrogen, we have 2 here. Carbon or oxygen is 3 times 2, which is 6. Oxygen is 3 here, 2 here, and the 1 here, making it 6. So the equation is balanced now. Then, by the relation between the reactant and the product, we have 2 moles of sodium hydrogen carbonate producing 1 mole of sodium carbonate, 1 mole of carbon 4 oxide, 1 mole of water. Then, let's get the question, the required, and the given. So from the question, they said, what is the mass of sodium triazocarbonate? So the required here, we are required to find mass of sodium triazocarbonate. Mass of sodium triazocarbonate produced. So we are interested with the mass here. Then we are given 33.6 grams of sodium hydrogen triazocarbonate. So the given here, we have 33.6 grams sodium hydrogen triazocarbonate. So we are now interested with sodium carbonate and sodium hydrogen carbonate. Now, because the equation is balanced, we now have to extract sodium triazocarbonate and sodium hydrogen carbonate, because that's where we are interested in. So here we have 2 moles of sodium hydrogen triazocarbonate and 1 mole of sodium carbonate. So we have to bring both of them out now. So here we have 2 moles of sodium hydrogen triazole carbonate produced 1 mole of sodium triazole carbonate. These are the ones we're interested. So these we produce. So at this point, we are required to find the mass of sodium carbonate. So we are interested with the mass here. And here we were given mass, which is 33.6 grams. So we are given mass. So what we are now comparing is the mass relationship, because we are given mass of the reactant and we are asked to find the mass of the product. So at this point, we term it mass relationship. So that's the relationship between mass of the reactant and the mass of the product. So based on the relationship, we are going to convert 2 moles of sodium hydrogen carbonate to mass. We also convert 1 mole of sodium carbonate to mass. That's their relationship before we now bring in the given in order to find the required. So to convert this, we have 2 moles. Sodium, the mass of sodium, we have 23. Hydrogen is 1. Carbon is 12. Oxygen is 16. Here is 3 times 3. So we simplify this. Although all this will be given to you like we have it, the atomic masses, it will be given. So we have 2, 23 plus 1, 24 plus 12, 36. 16 times 3 is 48. So we have 36 plus 48. We add it together. Let's get calculator to make the work easier for us. So we have 36 plus 48. We have 84. So we multiply 84 by 2. So we have 168. So what it now means is that we have 168 grams of sodium hydrogen triazole carbonate. Then let's see the mass of which 168 grams of sodium hydrogen triazole carbonate we produce. So at this point, we have sodium. Sodium is 23 times 2. Then plus, we have carbon as 12 plus oxygen here is 16 times 3. So at this point, we simplify 23 times 2. We give 46 plus 12 plus 16 times 3. We give 48. So we have to add it up. So 46 plus 12 plus 48. We are going to have 106 grams of sodium carbonate. Now look into this. At this point, we have 168 grams of sodium hydrogen carbonate, which will produce 106 grams of sodium hydrogen carbonate. So you cannot put it in this way. 168 grams of sodium hydrogen carbonate will produce, okay, or said produced 106 grams of sodium triazole carbonate. Now we've set up a relation that 106 grams of sodium triazole carbonate is produced by 168 grams of sodium hydrogen carbonate. Now the question that was given is 33.6 grams of sodium hydrogen carbonate. So if 33.6 grams of sodium hydrogen carbonate was used, Then what will be the product? What will be the mass of sodium carbonate? So we now say 33.6 gram of sodium hydrogen carbonate we produce now from the balanced equation, or from this you just cross multiply 33.6 times 106 divided by 168. So we produce 33.6 times 106 divided by 168. Now that will be the mass of sodium triiosocarbonate that will be produced. So use your calculator and simplify that. So we have 33.6 times 106 divided by 168. Then we are going to have 21.2 gram sodium triiosocarbonate as the answer. So we have option C as the correct option. So if what we did was able to help someone out there, please don't forget to subscribe, share, and turn on notification for others to learn as well.